All right, sketch the graph of each quadratic function. List the characteristics you use. So y equals negative 3x squared minus 21x minus 9. Well, look at that. Each of those is divisible by 3. So we're going to get 3 out of there. See if we can factor this to find the zeros. Y equals negative 3 times x squared plus 7x plus 3. Well, that doesn't factor nicely, does it? So I'm going to check with the discriminant to see if this does have any zeros and how many it has. So b squared is negative 21. Oh, gross. 21 squared is 441. I should have known that. 441 minus 4 times a, which is negative 3, times c, which is negative 9. So this is going to be a negative number. So the root 441 minus 4 times 9 is 36. 3 times 36 is 108, I think. I'm going to try. 4 times 3 times 9, 108 minus 108. 441 minus 108. 333. Okay, that doesn't factor into a whole number. So we're going to have to get the vertex with the difference of squares. Not difference of squares, I'm sorry. Completing the square. So we're going to turn this, complete the square here. So this equals 3 times x squared plus 7x. 7 divided by 2. Sorry, I'm going to rewrite this part here without that 3 kept in. So y equals negative 3 x squared plus 7x minus 9. Now, y equals negative 3 x squared plus 7x. Oh, 7x. This is not my best one. I apologize, everybody. X squared, all 2 of you that watch this. X squared plus 7x. 7 divided by 2. 7 over 2. That squared is 49 over 4. Minus 9. Now, 3 times 49 over 4. It's getting ugly, eh? 3 times 49 is 147. So we are, because we're taking that away, we're adding 147 over 4. It's not a very friendly question. This equals negative 3. So that's our a value. X plus the root of that, 7 over 2 squared. Now I have to figure this out. 9, if we want to find a common denominator, 9 times 4 is 36. So it's minus 36 over 4 plus 147 over 4. Negative 3 times x plus 7 over 2 squared. 147 minus 36 is 111. So plus 111 over 4. Here's a case where I wouldn't mind you using a decimal because you're going to have to use this to plot it. So the vertex is negative 7 over 2, comma 111 over 4, or negative 3.5. 27.75. 27.75. So we have the points of the vertex. All we need to do now is find the y-intercept, and then we will have 3 points to graph. The y-intercept is negative 9. So we're going to graph this thing. 27. Goodness. Do I have a ruler handy? Look at that. I do. Okay. Okay, I'm going to go by 3s, I think, maybe. Y-intercept's negative 9. This is unfortunate. I don't have enough space here. You know what? Maybe I'll draw it over here on this side, because I need to go really high. Let's just go from here to here. Let's see how this works. Okay, so the vertex is negative 3.5, so that's 1, 2, 3.5, negative 3.5, and then 27. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8. Okay, so barely enough. So if these are going to go up by 2s, these are going by ones. So this is 3.5, and this is going to be 27.75, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. 27's here, so right under 28 is going to be 27.5. Just to line up. There's the vertex. Now this whole thing is negative, so it opens down. We know we have a y-intercept of negative 9. 2, 4, 6, 8. So 9 would be right here. So this is not pretty. Kind of like that. Then the other point, you just move it across. This is over 3.5, right? So keep going another 3.5. There's your 0.5. 1, 2, 3. There's your other point. Identify these points. This one is 0 and negative 9. This one here is negative 7 and negative 9. Those are 2 points. Our third one is the vertex, which we have right here. It's not pretty, but that's the way it works. Hopefully that makes sense to you.